Hi, everyone. A very happy Tuesday and welcome back to our ARM Tech Talk series. My name's Tobias and I'm your host for today. This is the place for the latest and greatest trends, technologies, and best practices from ARM and our ecosystem partners. And I'm thrilled today that we're joined by Jonathan from Core, who's going to talk about unbrickable remote firmware updates and the use of TrustZone, which is something we haven't spoken about quite a lot in our ARM Tech Talk series for a while. And I'm really excited that they're able to join us today to give us that insight. You're going to learn a lot today from today's Tech Talk. I'm super excited by it, and I hope you are too. If you've attended one of these Tech Talks before, you know the drill of what's coming next. I've got a few housekeeping slides to go through, but I'm going to get through those as quick as I can because Jonathan's talk is really what you're here for today, not to listen to me. So Jonathan, when you're ready, if we could head to the next slide, please, that would be great. So if you want to get involved in the conversation today in any way, please use the hashtag ARM Tech Talks and on ARM to do so as well. Tag ARM, tag Core, tag myself and Jonathan. We'd love to hear how you found today's talk, and we'd love to hear from you. All of our Tech Talks are available on demand. We're close to 80 now, which is awesome. This is one of the best educations in ARM-based technologies and offerings from our partners out there. So do go and check them out. They're all on our YouTube channel, and subscribe for all the latest videos. We just released also last Friday a bunch of partner testimonial videos as well on our YouTube channel. So do go and check those out. Some really great companies listed there as well. And if you're like what you see today, and this is your first time, particularly welcome to you, and you want to sign up for any of our upcoming Tech Talks, then head to arm.com/Tech Talks to do so. Simple as that. And then if we want to get a sneak peek of what's coming up, Jonathan, if you'll mind heading to the next slide, we have a little sneak peek on our table. This is what's on our website as well, so you can go and sign up for these now. Next week, we're going to be joined by a speaker from ARM, Stephen Su from ARM, who's going to be talking about smart vision, which I'm really excited about. And then the week after that, we've got Linaro talking about ARM compiler optimizations with their Linaro benchmarking CI. So really excited about that one too. I'm always excited about these ARM Tech Talks. If you can't tell, they're a great education for you and a really great opportunity about the latest and greatest from ARM partners. And talking of that, we're going to hear from Core now. So before I hand over to Jonathan at Core, we've got a lovely little profile picture of him on the next slide, but you're going to see him appear on your Zoom screens in just a second. Jonathan, by introduction, is a product management director at Core, who's joining us from Cambridge. It's great to have someone in the same time zone. We normally have people joining from the US or elsewhere in Europe, or even in Asia, very late on the evening. So it's great to have you joining us, Jonathan. Before I hand over to you, audience, if you've got any questions for Jonathan at any point, please do use the Q&A box in the Zoom menu bar at the bottom to ask your questions. So Jonathan, it's great you could join us. Super excited for today's Tech Talk. Please.
Excellent. Yes, thanks, Tobias. Yeah, thank you very much for having me as well. So my name's Jonathan Williams, and I work at a company called Core Wireless, who you've probably not heard of. I'll explain a little bit about the group in the past, but my own background is that I started life very much as a hardware engineer, software engineer, mostly embedded software engineer, worked at semiconductor companies, amongst others. And now I run product management for what we call device builder platforms, which is our IoT device builder platforms here at Core Wireless. Before we get kind of stuck into the architecture and the technical ins and outs of TrustZone and how our approach to IoT works, I thought it's probably worth first thinking a little bit about how embedded software development kind of works, really. And essentially, I think one controversial opinion, or maybe it's not controversial, is that embedded development is kind of stuck in the past. When it comes to rolling out new features or fixes or updating use cases and business models, because you've got that embedded software component in there, it can be quite difficult. And part of that is because you have the obvious need for hardware as part of the overall solution. And that means it takes time for things to get to production, and big changes can be hard to make. But part of this, I think, is that the software development for the embedded world hasn't really changed much in the last 20 or 30 or so years. Essentially, the same model that we had 20 or 30 years ago, where you might design your product up front, design your hardware, and then build it. It takes a while. You implement your software. It seems to take forever or longer than it should do. And you then have to test some more until you can manufacture and deploy those units into the field. And that sort of design cycle from initial concept through to getting real products out there in the field in many cases that can take multiple years. We regularly see, products and customers with projects that take 2+ years to get out there into production. And if we compare that to the sort of, the more modern software approach of, web-based applications or businesses, then, they don't have the same kind of challenges as we do in the embedded world. Many of those businesses and business models really do operate in a much more agile approach of being able to, conceptualize an idea one week and deliver it next week so that customers can, A/B test it, and away we go. And I would like to think that we can build, the similar set of agility into the embedded world. And we talk about agile, in software, and really, I think in the embedded world, we kind of, we talk about agile, but really there's a lot of waterfall still going on. And you probably think that waterfall versus agile, and you probably think that, we've ditched our waterfall approach in favor of a more agile process, and so this doesn't really apply. But from a product perspective, when you think about rolling out your embedded software builds or your firmware builds and how often you get to do that, are your products and your customers really benefiting from a truly agile approach? Or is it still really kind of deadline driven, almost waterfall development cycles with a kind of agile methodology wrapped around them? And I think it kind of so often is. And that could be seen as controversial, but at the same time, it's worth kind of thinking about, what does it really take to open up embedded development to the actual world of kind of agile software development, and how might we do that? And what I really want you to be able to say, or what people to be able to say to their customers really is, we can make a feature release next week. We can try something in the field. We can roll a feature to a set of devices. We can test that feature or that UX enhancement or the product feature. We can test that in the field. We can implement it. We can really now operate on very short design development deploy cycles, just as we do for our other applications, our web-based applications, let's say. And in many ways, whilst what I'll talk about is kind of the embedded approach and how that works with TrustZone and how we're dependent on certain bits of hardware to make that work. But what we really are here to talk about is how, thinking a little differently about how you can deploy your IoT devices really can bring that agility to embedded software development. And I'll kind of explain this in terms of, our software architecture, our approach, and how that enables confidence and trust in you and your development team in a way that's never been done before. And it really means that whatever you actually do in your code, you can kind of be sure that your devices are recoverable. In the worst case, rollbackable. I'm not even sure that's even a word. But you can now really, because of that, you can now embrace a much more truly agile approach to embedded development in a way that's never really been possible before. Essentially with Core, kind of our goal is to bring that cloud-like agility to edge native development or embedded IoT development. And we do that with this Microvisor-based IoT architecture, which I'll go into. And this approach is only really possible now because of the ARM TrustZone and what that does in terms of enabling this software architecture. And I'll explain how that works. So essentially, what I've just described there in terms of bringing agility to the edge, that's quite a big promise. It's quite a big thing to say. But I'll dive into kind of how this all works now. But before that, I thought let's kind of look at some of those wider challenges around deploying IoT devices and why that kind of the idea of bringing a truly agile approach to IoT development has so far been so difficult. And we'll then look into the details behind the kind of combined ARM TrustZone and Core Microvisor approach to securing and connecting these devices, which ultimately makes your life much, much easier as someone responsible for your device fleet. And as part of this, we'll specifically cover, how an architecture behind Microvisor guarantees fail-safe or unbrickable over-the-air updates, and how we manage remote connectivity and security within that. And we'll also look at how a Microvisor architecture supports any programming language, any operating system, any CI/CD pipeline, and with that, any tool chain, meaning that you as a developer have complete control over your choice of development environment and firmware application. And as well as this, I've also got a video demonstration of the over-the-air upgrade capability and the secure remote debugging that Microvisor enables. So let's take a look at some of those challenges. Now, I'm only going to focus on a small subset of the many challenges that exist when it comes to deploying and maintaining a fleet of connected devices. For example, in speaking with many of our customers, managing connectivity of devices continues to be a major challenge. Whether that's the trickiness of making sure that a cellular connected device remains connected wherever it may be, or ensuring that it recovers quickly if there's a brief cellular network outage, or whether it's those devices connected on a local area network, for example, Wi-Fi or Ethernet. I think you kind of want to know that the devices that you've deployed remain connected. It's fairly basic, right? If you don't have connected devices, you don't really have much of an IoT capability, even if that connection to the device is not working only temporarily. If you imagine that you have or roll out a firmware version, and within that it has some software bug that affects the connectivity portion of maybe 10% of your deployed devices, perhaps the bug is that there's some kind of problem on boot that means that the device can no longer connect and is therefore unreachable. The cost of fixing that would be huge. I mean, nobody wants to have to go out there or send a person into the fields to go and recall bricked devices. It's prohibitively expensive. And as well as solid, reliable connectivity, we must also consider the overall security of IoT devices. Security continues to be the biggest challenge in the world of IoT, and always comes top of the list of concerns that companies and developers worry about when it comes to IoT devices. And one final thing to think about, how do you understand the ongoing maintenance cost of your devices? Whether that's the future cost of updating the security of those devices, or the technical support and maintenance cost when the inevitable things do go wrong. And I think this is a key factor that must be considered when planning a rollout of devices. And it's kind of often ignored at the design stage, but ultimately does affect the overall business case of those connected devices. And on top of thinking of the actual challenges of building and designing and shipping those IoT devices, I also spend a lot of time thinking about what I would really want and what my former colleagues and friends really want as embedded software engineers or builders of IoT devices. As I said, my background was that I spent a lot of time writing embedded code, mostly in C, sometimes in C++, sometimes even in assembler, not that I was very good at it, on a wide range of devices and with a complete mix of tool chains and IDEs. And for me, I know that while I want the benefits of a platform approach to building those devices, I kind of want reliable connectivity and trustworthy security and all of those things that a platform can bring. I also really know that what I really want is to write my code, my application, my firmware, my way, right? I don't really want to be told, you have to use these sets of libraries, you have to use this, you have to use that, you have to use this language. That's kind of restrictive. I also want to be able to choose what tool chain I want to use. I want to be able to choose what operating system I want to run on the device. And I want to be able to integrate any existing codes that I already have or make it work with my existing test harnesses or CI/CD pipelines. The more I can reuse or use what I want to do or what I want to use, the better. Well, within Core, we're kind of here to solve that hard problem of reliable device connectivity, as well as those of hardware security and fleet maintainability. So when you look to build a device with a Microvisor approach, and in this case with ST or with the ARM TrustZone device inside it, you want the assurance that your devices will maintain connectivity and be secure for the whole of the lifetime of their device. Architecturally, a Microvisor approach does this by making use of that ARM TrustZone component, in this case within the STM32U585 IC from ST Microelectronics. And we use the TrustZone to divide the microcontroller itself into two main sections at boot time. So peripherals are either assigned to the Microvisor zone or to the kind of customer firmware application zone. And those two sections get to run code independently of each other. Effectively, our implementation, which kind of makes full use of the TrustZone hardware, enables us to provide a hardware-enabled hypervisor which runs separately from the application or your firmware running on the device. And this hypervisor implementation approach on an MCU, that is the core microvisor itself. And I think what we've kind of seen is that, lots of people look to use the TrustZone as a sort of security acceleration piece. But nobody, apart from us, has kind of looked to use the TrustZone to run or separate all of the kind of connectivity stack from the application code. And it's that kind of, unique use of TrustZone which kind of really makes this possible. So essentially, the split in responsibility, as I've just described, this means that Microvisor takes care of everything needed for your device to remain connected. It's the hardware-based hypervisor approach, only made possible with the ARM TrustZone component there, that enables that physical separation between the application code or the firmware code that may have just encountered an otherwise fatal software bug, and the software stack or connectivity stack that's running everything connectivity-wise on the edge device. i.e., the core Microvisor takes care of all of the connectivity from the edge device to the cloud. We're responsible for the IP stack, as well as the Wi-Fi and or cellular modem, firmware and drivers, i.e., everything your device requires to remain connected. And with the core Microvisor running alongside your application, separately managing the connectivity software on your device, then even in the worst case scenario, you can still reach and recover your devices. And it's this key capability that your devices now have that is one of the pillars of enabling unbrickable over-the-air firmware updates. Even if your application has crashed or it's stuck in some kind of infinite loop, or it's, as we described earlier, maybe it can't boot for some strange reason, because the Microvisor component and everything connectivity is completely separate from that firmware, then your device is still connected and reachable. So because that Microvisor component and all those bits in red on this diagram is still connected and reachable. And what does this mean for your application or your firmware development? Well, this complete separation of the application space or the firmware space to the Microvisor space is kind of significant in a number of ways. And we'll get onto a few of the features that we enable with that later on. But I think the most significant for you as a developer is that it means that the application gets to be anything you want it to be. Microvisor now operates completely independently of your firmware code, and you interact with it across a secure interface and a series of simple system calls. So this means that if you want to use ThreadX or Azure RTOS and some existing code that you already have, then you can. Equally, if you want to use FreeRTOS and the many examples and drivers that are available online, you can. Same for Zephyr or any other operating system that you might want to use. Equally, if you already have or you want to roll your own bare metal code in whatever language or environment you like, you can do that too. Be it C or MicroPython or Rust or Assembler, you can basically use anything. We've even got one customer today looking at porting a .NET environment onto an ST chip in order to use Microvisor alongside and a .NET environment. Essentially, anything that can run on the ARM core, on the ST chip in this case, that you want to use on a device, then you can do that with Microvisor running completely independently alongside. I think this is a kind of major difference between pretty much every other IoT platform that's out there today. Essentially, Microvisor allows you to write your code your way with full access and direct access to the underlying hardware on the chip. But you now benefit from all of the features that an IoT platform brings, but without having to modify your code or your development approach. And this also applies to your development tools and toolchain. Pushing an application to a Microvisor-enabled device can be integrated into your CI/CD process very easily. And as well as having the complete freedom to choose your programming language, development tools, IDE, etc., a Microvisor approach, where the Microvisor is running separately alongside your firmware separated by that TrustZone, means that you have direct access to the underlying hardware, just as if Microvisor wasn't there. I.e., unlike any other platform approaches, there's no platform code that sits between your code and the hardware. Your code gets to run directly, natively on the hardware. And because of this, your firmware gets to run natively, as I just said, and that enables near real-time use cases to be implemented. Another pretty important platform feature, I would say. But what all of this really means is the risk to you as a developer is pretty low. If you build an application or build some firmware and you want to use Microvisor to push it to your devices, you can. And if you later decide that a Microvisor approach isn't for you, then you haven't really lost anything, because you haven't had to tie your code and your environment into the ways of the platform as it was. All of the code that you've written and you've got for the target device is still yours and can still work for you. So there's kind of nothing to lose, as it was. In terms of the device level implementation, Microvisor approach gives you managed connectivity and security for the lifetime of your device. You get to focus on your application, while we at Core take care of the connectivity and keeping your devices online 24/7. And we also maintain the security of those connectivity and IP stacks on the device. As we're here to talk about, you get to benefit from unbrickable over-the-air firmware updates and secure remote debugging. And these things enable the more agile approach to the IoT device that I explained earlier. And I'll explain a little bit about more of these shortly. You also get to rely on the industry-leading approach to security. Both secure boot and secure factory provisioning means that only your code gets to run on only your devices. An easy thing to say, but an important one to think about. It means that you can now make sure that you can manufacture your devices in an insecure factory environment, which essentially nearly all factory environments are. And that's an often overlooked, but I think a fundamental must-have in the world of IoT security. So essentially, a Microvisor approach divides the problem of building an IoT device, into separating those must-have bits of connectivity and security and the features like unbrickable over-the-air firmware updates and secure live remote debugging. And that leaves you to focus 100% of your development team's efforts on building whatever your firmware or your application is actually there to do. And you can do that in whatever language and with whatever operating system you want to do it with. Now, a little bit more about the details or how that enables really the sort of agile development approach. And I'll go into those details in a minute. But essentially, if you now have the ability to push firmware to devices, at will, that you have an unbrickable firmware update, even in the worst case scenario, you push a version to an active device in the field, and that firmware version, itself has some fatal bug that means it can't boot. But you now know that you can recover it because connectivity is working and away you go. That, I think, changes the entire mindset and approach that you and your development team now have. That ability to develop features quicker, to fix bugs on real devices in the field, enables that agility that I was talking about at the beginning. And that, I think, enables an almost completely different way of thinking about how do we as a development team develop software for embedded IoT devices. And I think that's pretty exciting. Now, a little bit more on some of the tech details. Now, this team, the embedded team, the device team, the cloud team here at Core, we were previously at a company called Twilio, which you might know from sort of programmable SMS messaging, amongst other things. And prior to that, we were at a startup called Electric Imp, sort of based here in Cambridge and across in the US. So we've kind of been working on this problem and with ARM devices for 10 plus years now. And we've delivered and maintained millions of IoT devices through the various device builder platforms that we have in the market today. But I thought it might be worth a little bit of covering a little bit of detail why we at Core specifically chose our first part to be, or first supported part to be, the STM32U5 family of devices. So obviously, firstly, the U5 device has the TrustZone component that we talked about, which really is essential for kind of making this entire architecture possible. It also has industry-leading security, notably the secure AES and PKI implementations, as well as that secure boot functionality that enables the secure factory that I mentioned. And that secure boot really is a foundational component of building a properly secure implementation. We also mentioned, as I said, the complete secure factory provisioning implementation for you to use in your factory. And this enables you to manufacture your devices in factories anywhere in the world completely securely. We do this by building on top of the building blocks of the STSFI, or Secure Firmware Install Process, which again, helps guarantee the security of your devices out there. And I would say, again, another thing that really is quite important when it comes to building IoT devices. I think it's fair to say, and I'm happy for people to kind of challenge me on this really, but I think it's fair to say that the combined approach of a microvisor, or separating the security and connectivity stack on a device, with the kind of industry leading part, based on ARM, the M33 core and TrustZone here, and the U585, I think this is the most secure approach to building IoT devices that's available today. So on to kind of, the reason for being here. How do we support the unbrickable over-the-air firmware updates that we're talking of here in this webinar? Well, as you kind of seen, the division of responsibilities in the Microvisor architecture ensures reliable and consistent connectivity for IoT devices. The Microvisor takes care of maintaining the IP stack and the firmware and the drivers, be that Wi-Fi or cellular, whatever connectivity you want. So everything your device needs to get connected. And that separation of the connectivity stack brings that first benefit when it comes to unbrickable over-the-air firmware updates. Your device now remains connected, even if your application or your firmware has stopped running. Maybe it's even crashed. So even if it's continuously crashing on startup in a loop, which would otherwise be a kind of a fatal problem to have, the device itself is still reachable, still upgradable, and therefore recoverable. And a second benefit of a Microvisor approach is that Microvisor takes care of moving the data required to apply an update from the cloud to a staging area in the QSPI storage, where it remains encrypted. So once the device has all of the changed parts of the application or firmware stored safely in that area, it then applies a single update to the firmware application file system of the device. And that ensures that the upgrade is applied in a fail-safe and restartable way. It's an atomic operation, really. So that upgrade being atomic from the application's point of view, but without needing to store multiple copies of the firmware in the staging area. And that saves you the usual flash space that you might need to store multiple copies of the firmware if you were trying to roll back a device, which is so often the approach that's taken. And on top of that flash space, saving, as with any approach to over-the-air firmware updates, kind of saving bandwidth is also critical, especially for cellular connected devices, where you incur costs for data usage. And the Microvisor over-the-air protocol kind of takes this into account. So we only download and stage the layers of the file system and application that need to be changed. You get to ensure that the only differences that are sent to each device are sent over the air. And that optimizes the download time, the bandwidth usage, and ultimately the incurred cost to you. So in terms of, how does that work in practice? Well, it can, be seen as being a very simple operation, really. Essentially, if you want to update the firmware or application to one of your devices in the field, or to many of your devices in the field, then it's now a simple API call to the Microvisor service. So here you'll see the Microvisor service, which is kind of in, as I mentioned, we were acquired by Twilio earlier this year. So you'll see Twilio in a couple of these things, but the core Microvisor service is running in the cloud there. You make a simple command call or API call to the Microvisor service, push a firmware version to that device, and that firmware version is then remotely sent to your device and your device upgrades. So you now have a really simple way to upgrade or update one or many of your devices. And through the same mechanism, you can now also roll back your firmware and application to a previously working version. And on top of Microvisor providing the edge device with connectivity, security, and unbrickable over-the-air firmware updates that we've just talked about, Microvisor also provides the ability for you to securely remotely debug the application itself in real time. And if we think back to that situation of a device perhaps crashing on boot, wouldn't it be great to be able to kind of, go and find out what's going wrong with that device in real time and single step through that and see what's going on and potentially even fix the device in the field. So secure live remote debugging enables you to do exactly this over a Wi-Fi connection or a cellular connection to a device, potentially anywhere in the world. And we do this by tunneling the GDB debug protocol from your local development PC or Mac all the way to the edge device itself, wherever it is in the world. The command line tool and the Microvisor plugin enable you to run a local GDB server on your development PC, and you hook up your own tool chain or integrate debug experience IDE, whatever, just as you might do with a device that you're debugging locally on your desk. And that local server then connects through the core Microvisor service directly to the edge device that you want to debug. I mean, it could be an actual customer device in the field that's reporting an issue that you otherwise can't reproduce, for example. And this connection is transparently routed over the cellular connection, which could be powered by one of our core super SIMs, or it could be connected via Wi-Fi or Ethernet to your device in the field. And that enables you to access all of the capabilities of your choice of debugger, whether that's command line based or GUI based, that you need to figure out what went wrong with your application. Secure remote debug enables you as a device builder to respond much, much faster when the inevitable device-side bugs do occur. It means that you can remotely connect to the actual device in the field that's experiencing the issue, single step through the code, deploy a fix, without leaving to having to leave the comfort of your desk or office. I think that's pretty cool, and I'm as far as I'm aware, it's not something that anybody else has really enabled. So enough about kind of how that unbrickable over-the-air firmware updates work and secure remote debugging. I've got a quick video demonstration here that kind of runs over how that works. And again, you'll see bits of Twilio mentioned here, but this is obviously now part of core. So as I said, the first device that we support is the STM32U5 IC, which you see in the middle of this board. On top of that, we've got a cellular modem. And in this case, the device is connected over cellular connectivity. We've just got the USB connection there for power. And as an application, or the firmware that we've got running on this device is actually a FreeRTOS based application. And in this case, we're using VS Code as our IDE. But as I said, whatever IDE or OS or whatever it is you want to run on the chip, you can. So as I mentioned, we can now, in order to securely remotely debug this, then you actually create a public-private key pair that's unique to you in order to kind of debug your device. You then, when you build your firmware or application, and again, all of these commands can be integrated into your process, into your flow. But when you build the application, you pass in one of those keys, and you build the application just as you would normally do in a device. In this case, we're taking the actual identifier of the device itself and putting that into the commands. And that then allows us to now establish that secure tunnel or that secure remote debug connection to the device. So here you'll see, this is our very simple application, written in C, running on FreeRTOS. Just as you would if you had a device on your desk and you wanted to connect to it locally, attach the debugger to the device. So you can see here, the application, the counter stopped counting, but you can still see that LED blinking on the board. So that indicates that the Microvisor is still running, but the application has stopped. At that point, we can restart or hit continue. The device then runs. And if we want to, we can then set a breakpoint. So let's stop the device. And then it'll stop somewhere deep in FreeRTOS, so in task.c in this case. We can then set a breakpoint in the device, in the firmware itself. So let's go into main. Let's find that loop that's updating the counter, and let's set a breakpoint and restart that device. And again, just as if the device was connected locally, over a cable, the device now stops. It hits the breakpoint. We can now inspect those variables. So everything that you would expect to be able to do from a debugger perspective, we can set those variables, we can reset them, and we can restart. So in this case, let's change the value that's in the variable that governs the number on the counter. let's clear the breakpoint and then hit restart. So if we imagine that's the kind of the bug that we found, fixed and updated, and then hit go, we've now completely restarted that device. And that kind of shows, I mean, it's a bit of a contrived application, but it kind of shows, the power of being able to securely, remotely debug a device that is anywhere in the world. So in this case, that was, as I said, over a cellular connection. So it could be, in a field in the middle of nowhere. It could be in a factory somewhere connected over Wi-Fi. But you can now go in there, single step through a device, and push a new firmware to that device. I think that's pretty cool and pretty exciting. In order just to kind of wrap up in terms of what those features really mean and why IoT has been so difficult for many people up to now, is that I think one of the kind of mistakes or challenges of IoT, or one of the mistakes that people make is that in many ways IoT seems to be very simple. You have a device that's an embedded device. It has a bit of hardware, an operating system, an application or firmware. Maybe you've got some keys and some something you need to connect through to your back end. For example, AWS, let's say. You choose a cloud, you have connectivity, you connect your device, and away you go, right? I mean, how hard can it be? But it turns out it's actually quite hard. If you think about it, it's not really just one device connected to one cloud and the data with that. When you've got multiple devices and a DevOps team, you've got to worry about security, you've got to worry about operations, you've got to worry about making sure those devices stay online. Whether it's, devices in Europe, devices in the US, devices in goodness knows where, all of those problems of managing and maintaining a fleet of devices, it really is a quite a complex problem to kind of manage. And we see that the kind of that problem of how do you, take more than just one device connected to one cloud, and get a demo type device. How do we turn that into an actual fleet that's deployed and working reliably out there in the field? And that challenge can be, quite a big one for many customers. And what we really achieve here, I think, with a Microvisor approach, is that we kind of separate those two problems. The problem of my device and my data, I just want to get it to the cloud, which is what people almost always say. Versus that every day, how do I manage and maintain a fleet of devices? How do I make sure they stay online? How do I make sure that they secure? And how do I manage that sort of DevOps type functionality of making sure that tens or hundreds of thousands of devices are up and running 24/7? And that's kind of where we come in. And I think that logical split on the device using the ARM TrustZone that enables, the separation of connectivity to the application or the firmware, I think that really enables, you to focus, as I said, on, the smarts of your device that make your product and your business case work. And we at Core then worry about making sure that all of those devices in the world are online and secure, just as they should be. And I think it's, only when you think about IoT in terms of those two separate problems of, how do I get a device connected versus how do I keep my tens of thousands of devices connected? I think that's a really important way to think about it. So one final kind of look of kind of where we come in, if you look at the traditional IoT or device side stack, when it comes to modules and sensors, and in today with our partnership with ST and obviously the ARM component, ARM M33 and TrustZone that's in there, making sure your hardware is secure. As I said, you get to worry about your firmware, your application, and your back end without having to worry about, how do my devices get connected, be that over cellular, Bluetooth low energy, Wi-Fi, or Ethernet connectivity. And I think that approach, particularly a Microvisor approach, is what really enables you to now think in a much more, I think, agile way in terms of how do we develop our features and our applications and push those out to our customers. One final thing to kind of stop on is obviously, hopefully you've kind of enjoyed what we've talked about today, and you've seen the demo and the unbrickable over-the-air firmware updates and the secure live remote debugging. So the obvious question is, how do I get my hands on one? or how do I get started? Well, you can get started by going to corewireless.com/mv-signup. And at that point, there's a form to fill in, and myself and the team will get back to you and get you up and running. Or you can email me or email the team, actually, at microvisor@corewireless.com. And either of those approaches, we should be able to help you get started. And that board that you see on the left there, which contains the STM32 chip that I mentioned, plus a cellular modem, plus a Wi-Fi and Ethernet coprocessor as well. That board, we can get you one of those boards. We have a kind of giveaway on those boards at the moment that if you have an application that you're working on and you want to get up and running, writing your code on an ARM-based platform, then we can get you one of those boards today, and we can get you up and running very, very quickly. So with that, I'm pretty much done at my end. And back over to Tobias. I guess we've got some Q&A, have we?
I think it's time for Q&A. Thank you, Jonathan. That was an awesome tech talk. Really, really great stuff. And I hope you also enjoyed it as well, folks on the call. So let's get to Q&A time. Let's leave that slide up there, actually, Jonathan. I was going to say move to the next slide, but let's leave that one up because I think people will be QR code scanning and typing and copying and pasting things. So we'll leave that up for a couple more minutes just while you're doing that. So as Jonathan said, now it's Q&A time. I've got a couple of questions. I mean, the first one I'm sure people want to know is about cost. What's the kind of cost and how people want to ask, what's the cost? How can I get my hands on it? Do you want to just talk a bit more briefly about the commercial side of it and the cost side of things?
Yeah, so we've got a couple of different models that we work with, but essentially, providing that ongoing connectivity and security as a service is kind of our model. So we have a model where you can treat the cost of the Microvisor connection and connectivity as a sort of per device per month fee. So in the months where your devices connect, then we charge you per device per month, as it was. And that really works well for those kind of applications and business models that have an ongoing element to it. Typically we see that with cellular based devices. You're kind of already paying a monthly cost with that. So that's a good way to kind of factor that in. But we also have a model for those people that kind of don't want the kind of ongoing cost element. So an upfront option. So you can, if you want, you can upfront pay for the Microvisor for the lifetime of your device as well. So both of those options kind of are available. In terms of where costs start, and obviously it depends on applications and volumes and things. But essentially, if you think about a device as being roughly $1 per device per month is kind of where our costs start for a Microvisor approach.
Amazing. Thank you, Jonathan. That's really great. And I'd love to delve into a bit more about the kind of ARM products you support, right? Because you talked about the STM32 part.
Yeah.
What other ARM-based products out there do you currently support today, or that you be supporting soon?
Excellent. Yeah, no, that's a great question, one that comes up quite a lot. So obviously we've kind of initially worked with a specific ST part, which is the STM32U5 family of devices. And the reason for doing that, I kind of touched on in the presentation a bit. There are other parts that we intend to support. And essentially, any, let's say, M series with ARM TrustZone could be supported in a Microvisor world in the future. So that's other ST parts. So if you see the latest STM32H5, for example, is quite a good part, and we're kind of looking at that now. It could be other non-STM parts as well. So there's parts from Renesas, there's parts from other vendors out there. Essentially, what I think we're seeing that the kind of adoption of let's say M33 and ARM TrustZone across everybody's roadmap or everybody's portfolio of parts. So really, enabling or using Microvisor on any of those parts in the future becomes possible. I would say, and that's definitely the way that the world is moving. Initially today, as I said, it's the STM32U5 family, which enables you to get up and running. And what we've seen is, the majority of kind of people and use cases that are out there today are kind of okay with making that choice today to use the ST chip. But if you have requirements for other parts that you've seen that you'd love to use Microvisor with, then yeah, let me know and we'll see what we can do.
Get in contact, exactly. Reach out. That's what's great about these things, and I'm sure people will do in addition to entering the giveaway. So we do have a couple of questions coming in. I've got one final one for you on my side that I'd love to get your answer on, is around the kind of device key and certification management, right? So if I want to connect to AWS, how do you handle something like that?
Oh, that's a great question. I probably, maybe I should have had a slide on this in there, and I think I mentioned keys once, but yeah. I think one of the big challenges can be, how do I connect my device to, let's say, AWS IoT or Azure IoT? So we provide system calls on the device that allow you to talk to, let's say, AWS IoT via MQTT, just as you might expect. But one of the kind of big benefits of, again, this sort of microvisor approach is that your devices don't have to be tied to one of these cloud vendors. Typically you'd build a monolithic firmware application, you might embed your keys in it, don't do that, or you might have some key provisioning system, do that, and you push those two devices, you connect them to AWS, and away you go. In 2 years' time, let's say you want to change your mind, or you want to go and make use of some other cloud middleware provider. How do you do that? Really hard, probably a product recall. Maybe you can work out a way to do it, but it's quite hard. But one of the things that Microvisor does is we provide an out-of-band mechanism for getting certificates and keys down to a device, as well as that over-the-air firmware upgrade. So you can now, theoretically, you could have a device that's in the field talking to, let's say, Azure at the back end. You then change your mind and want it to connect to AWS. You can reprovision it, send keys out of band, and connect it to AWS. Let's say you want to roll your keys or change your certs, then you can do that as well. And again, when it comes to security, everybody wants to have the best security, but there are always design hurdles and development hurdles, and people always say, "Oh yes, we're going to do that, but we haven't got there yet." With this and with our approach, you kind of get class-leading security from the start, and that includes provisioning of keys and certificates, and it means that you're kind of not tied into one of those cloud providers, which I'd like to think is always a good thing.
Absolutely, and it's really great to see that the ubiquity of the offering, and it's great to see that kind of cloud to edge story and the ubiquity of ARM TrustZone and ARM technology involved throughout. So exactly. Yeah, it's really great to see that comprehensive offering. So let's get to some audience questions. So we've had and if you do get questions in, we've still got about just over 5-10 minutes or so. So do get your questions in, and if you like a question, just hit the thumbs up button. I'll get to those first. So currently the top one I've got is around RTOSes, and I think you did mention this on a slide earlier, but it might just be good to kind of go back on that. I'll delve a bit deeper into it around the RTOSes supporting this microvisor paradigm, specifically FreeRTOS and embed was the question.
Great question. Yeah, so essentially the answer is any operating system or anything you have that you can build, compile, run on, let's say, this specific ST chip today, you can make that work with Microvisor running alongside. In practice, that means different things depending on what you're doing. So, FreeRTOS or Azure RTOS or Zephyr or any of those things, pretty simple, right? You add support for the Microvisor specific bits of the HAL that have changed. You make use of the Microvisor system calls if you want to use them, and then you hit build, and you can deploy an application that you've built, let's say on FreeRTOS, and push that to a Microvisor enabled device. You could probably do that in a couple of hours. It really is straightforward. With embed, similar but slightly different. Obviously, embed, includes some of those stack components. So there's a little bit of separation in terms of how you would use that, because obviously now the connectivity stack is running on the Microvisor side of the house. But again, totally possible. You could run an embed based firmware application, make use of the system calls to talk, let's say, to MQTT through to AWS IoT, and away you go. I think I mentioned in the talk, I've got, one customer out there looking to port a .NET environment, which, seems a bit crazy, but at the same time, it's possible, right? You can run that on an ST chip today. And if that's what you want to do, then, how would you build an IoT device based on that? And the answer is you build your application, deploy it with Microvisor, and you just go. And that is pretty cool. So I think having that kind of freedom and flexibility for any operating system, whatever programming language you like. I know myself as an embedded software developer, I always had my ways of doing things. I know other people have their ways of doing things, and I think that's really important.
Brilliant, very comprehensive answer. Thank you, Jonathan. That's really great, and I hope that answers your question. I think it was it George who asked that? Yes, George asked that. So got a question in here from Attila. Again, apologies for any name mispronunciation in any of these. So there's a kind of few back to back here. So I'll list them out. You can maybe take them one by one or combine them together.
Yeah.
How much flash/RAM is consumed by the Microvisor operation during normal operation?
Yeah.
And then how much time does the MCU spend in the Microvisor? And is it the Microvisor itself updatable? Can they change keys, etc.? So I don't know, you want to take those? You want to do the kind of flash RAM consumption by the Microvisor? How much? Or
great questions. Yeah. So the answer is that we in Microvisor have we've worked out how much flash and RAM we are going to use in the future for the lifetime of the Microvisor. So today we reserve roughly half the flash and a third of the RAM that's on that U5 IC. So you get the remaining half of the internal flash, plus there's an external QSPI flash component as well. And then we've taken roughly a third of the RAM. And the guarantee that we make is that we won't consume more than that in the future. And that, I think, is quite important because if you've worked in IoT, then you might be aware of platforms that have kind of constantly shifted the goals or the boundaries in terms of how much flash and RAM they use, which might well be where the question's coming from. And that can be a real problem, right? If you if that constantly changes, then you now have to retest your app, your firmware against the platform, at which point you've kind of lost all the benefits of having a platform in the first place. With Microvisor, the idea is that the Microvisor gets updated. You don't have to retest at all. You get to carry on. You can deploy your firmware and never worry about it ever again, knowing that it will still work in 10 years' time, and it will be more secure than the day you built it, which is pretty cool. In terms of MCU time and time spent for the MCU, again, a great question. In simple terms, the answer is not much different to what you would have if you just built a monolithic application with the connectivity, the device drivers, the IP stack in your firmware. Obviously the interrupts for the device drivers for the cellular modem, for example, they take priority over certain things. In a Microvisor split, Microvisor, interrupts the application code, handles those messages, and sends them on to your application. So the actual time that your application gets to spend is essentially the same as it would be in a monolithic app as it is with a split application. It's just that there's slightly less control because Microvisor interrupts things and runs at a slightly higher priority. But essentially, the amount of time that you get from an MCU perspective is the same as it would be. In terms of the Microvisor updating itself, yes. I could go into details, but we probably haven't got too much time here. But essentially, the Microvisor itself is also updatable over the cellular interface, and we get to manage that, or we manage that, on your behalf. But as I said, you don't have to worry about that component as it was, and we use the external QSPI to stage that update. And then in terms of keys, for the application level keys, then as I said, we've got that out of band mechanism of pushing keys down to the device, or keys or certs out of band via the Microvisor service, via an API, down to one or many of your devices. So that's all possible today, I would say.
Awesome. Thank you, Jonathan. And we've still got a couple more questions, but would you mind thinking just to the last slide? I'm going to interrupt your Q&A briefly for a little promo shout out for ARM TV, and then we'll cover the last couple of questions. So on the 19th of October, I think, is there a slide just after this one? I think, is it the one just after it? I believe. There we go. There's the QR code. I'm going to paste the link in the chat as well. So you can go and check that out as well. We have a really exciting ARM TV episode, 10 a.m. Eastern, 2 p.m. UTC on October the 19th from Dr. Raman Chowdhury on how they're hacking AI to shape the future of humanity. So if that sounds interesting to you, go and check that out. Scan the QR code, register now. We'd love you to register, and there's a lot of ARM content that's coming out this week, and with this and ARM TV, and of course we have Innovation Coffee on Thursday, so do check those out as well. So we'll just leave that up there for a second. Let's cover the last couple of questions, Speedy Gonzalez style. Following on for the kind of update question was around how do you initiate firmware updates to all devices at the same time? Does it phone home? So you have a list of IP addresses and then you upload the firmware to each of them in turn. That's from Dan.
Yeah, great question. Yeah. So how do you initiate firmware updates at the same time? Right. It's not doesn't really work that way. So does the Microvisor phone home? Yeah, kind of. So let's say you've got 10,000 devices, they're out there. You get to control at the device side how often those devices make a connection. So, maybe you've got an Ethernet connected device and it's essentially permanently online, and sockets and everything's established and away you go. Or you've got a cellular device and it pings home, once a week because it's sat in a field somewhere and it's running on batteries and you don't want it to go flat. When that device connects to and through the Microvisor service and you've scheduled a firmware update for it, it will then download that firmware update and schedule an update. So essentially it's a device side control that decides when those devices update, and that often depends on the connectivity bearer and whether it's battery powered and all of those things. But essentially, you get to divide in this device side code when your device connects, and then when it connects, it will get updated. In terms of do you upload the firmware once for each device? No. Essentially, you upload the firmware to the Microvisor cloud in the back end there, and then you get to decide which devices get which firmware versions. So you could have devices which are your development devices, which obviously get firmware updates all the time, and you could have devices in your production fleet that you only push once a week or once a month or once whatever your policy is.
Brilliant, thank you for that. And then we've got one final very short question from Hans that says post-quantum encryption.
Wow. I'm not even sure what that question really means.
No.
I can answer a few things. Obviously, there's a couple of companies out there that are doing some fairly cool things in terms of quantum-based encryption, and there are certain things that you can run on the ST parts and others and make use of, particularly for individual device IDs, for example. In terms of do we use that? No, not today. Could you use that in the future? Yeah, of course you could. What we do is we individually key, I guess, each device at point of manufacture. So each device is individually identified and completely has its own set of keys and is secure from that point of view. But it's not a quantum based thing today, but I guess it could be in the future.
Yes, exactly. The future is long. So who knows? Well, look, I think we're going to have to wrap it up there because we're just over time. Jonathan, any final words from you before we wrap up today's ARM Tech Talk?
I think that's been great. Yeah, thank you very much for having me. I hope that obviously anyone that has stayed along for the ride and enjoyed what we've talked about, please do contact us either at Microvisor at corewireless.com or via that QR code and link that's posted in the chat. And then we can look to get you a development board and get you up and running, and you too can have a play with Microvisor and see what it can do for you.
Brilliant. Thank you, Jonathan. That was an awesome tech talk. Great demo. Lots of fantastic content. Audience, I hope you enjoyed it just as much as I did. And if you love these ARM Tech Talks just as much as we do, then tune in next week, same time, 4 p.m. UK, 8 a.m. Pacific for another ARM Tech Talks. And that one's going to be on Smart Vision, which is going to be really exciting. And it's a rare occurrence because ARM's actually presented this one. It's not a partner. But you'll be able to hear a lot about what we're doing with our partners in that one. So do tune in for that, same time next week. Jonathan, thanks so much. We hope to have you back again very soon for another ARM Tech Talk. And audience, we hope to see you again for another ARM Tech Talk as well. Have a good day, everyone.